Hello everyone, today we're going to be working on fundamental problem 6.6, and this problem is asking us to determine the force in the members AB, AE, BC, BD, BE, CD, and DE. So as you guys can see, we have two forces acting on this truss. We have the 600 pounds acting on point E going downwards, and the 410 pounds acting to the right, also at point E. So the first thing that I'm going to do is I'm going to determine the reactions. So if we were to take a look at our point A, we know that we have a pin support, meaning that we're going to be having two reactions. We're going to be having our vertical and horizontal reaction. I'm going to assume that the for the vertical reaction, it's going to be going upwards. And then from there, I'm going to assume that the horizontal reaction is going to be going to the left. And then from there, if we were to take a look at C, we could see that we have a roller support, meaning we're only going to have one reaction. I'm going to assume that the reaction is also going to be going upwards. So now that we determined that there's going to be three actions, from there we can proceed to finding their values. I'm going to be taking the sum of the forces in the x direction. That way we do the 410 and the a of x, solving for a of x. If we were to solve for a of x, we would end up getting that a of x has a value of 410 pounds. We got a positive number, meaning that we assumed correctly, so we do know that that reaction will be going to the left. From there, if we were to take the sum of the forces in the y direction, we'd have two unknowns, ay and cy. So that's why instead I'm going to be taking the sum of the moment about point A. That way, the reaction ay would not be creating a moment, meaning that we'd be able to solve for c of y. So here we know that AY would not be creating a moment as well as the reaction AX. If we were to look up here, the 600 pounds would not be creating a reaction as well. The only force from point E would be the 410 pounds. Remember that the moment is equal to the force times the distance. The force would be 410 pounds. As for the distance, so to determine the length, what I'm going to do is I'm going to do this. So you guys could see this big triangle that we have here. We know that from this triangle, this angle right here is an angle of 30 degrees, right? And we know that this bottom length has a total length of 6 feet. So what I'm going to do is I'm going to be doing the tangent of 30 because tangent is opposite over adjacent. We're trying to determine the opposite side of that angle. We're trying to determine the length. And then we know the adjacent side. So I'm going to do tangent 30 times 6 feet to give us the length of this side of the triangle. So we have tangent of 30 times 6 feet should give us the length of that. And we get 2 times the square root of 3. So, okay, now going back, remember moment is equal to the force times the distance. The force is the 410 pounds. The distance we now know is 2, 2 times the square root of 3. As for positive or negative moment, this is going to be creating that clockwise moment, meaning a negative moment. So for the first one, we have a negative moment with a force of 410 pounds times 2 to the square root of 2 times square root of 3 feet. And then from there, we have our C of y, that's going to be creating that counterclockwise moment, meaning positive moment. Our force we're trying to determine, and then our distance is 6 feet. We know that all of that has to equal 0. If we were to solve for this, we end up getting that our C of y is equal to 236.7 pounds. We got a positive number, meaning that we assumed correctly, so we know that this reaction will be going upwards. From there, now I'm going to be taking the sum of the forces in the y direction to determine the last reaction. So from there, we have our C of y, our 600 pounds, and then our ace of y. If we were to solve for ace of y, we end up getting that ace of y comes out to having a value of 363.3 pounds, positive number, meaning we assume correctly, meaning that this reaction will also be going upwards. So now that we found all of the values of our reaction, the next thing that we're going to do is to determine the force of the members. What I'm going to be using is the method of joints. So our second step would be using method of joints. And the first joint that I'm going to start off with is joint A. So if we were to draw joint A, we'd have our reaction A of Y with a value of 363.3 pounds. Then we have our reaction AX with 410 pounds. From there, we have our bar or our member AE. I'm going to assume that it's in tension, so away from the joint. We're going to call this force AE. And then from there, we have our member AB. Again, I'm going to assume that it's in tension, so away from the joint. So I'm just going to be taking the sum of the forces in the X and Y direction to determine the values of these members. We got a positive number, meaning that this member is going to be in tension. If you get a negative number, that means that it will be in compression. So now we're going to take the sum of the forces in the Y direction. Hmm, hold on. I don't know why I wrote this as negative. That's positive. There we go. Since we got a negative number, that means that this member is going to be in compression. So with that, we already found these two members. So now I'm going to be taking the method of joints about joint C. Now, so if we were to draw out joint C, at joint C, we'd have our reaction C of Y going upwards with a value of 263.7 pounds. From there, we'd have our member BC. I'm going to assume that it's in tension, so away from the joint. So the force of the member BC. And then from there, we have that our member CD that's like at an angle. I'm going to assume that it's also in tension, so away. So force CD, sorry. So as you guys could know, force CD has both a horizontal and vertical component to it. So that's something to take in consideration. And remember, we do know that this angle right here has an has a we have an angle of 30 degrees, so we're going to write that in. So I'm going to be taking the sum of the forces in the y direction right now. So we have our reaction of 263.7 pounds. From there, we have that component of our force CD. So to determine the vertical reaction to that, if we were to take a look at this like a triangle, we'd be trying to determine this side of the triangle since that's the vertical component of the triangle. So that's the opposite side of this angle. And then from there, we're dealing with the hypotenuse side of that triangle. So we're going to be multiplying the force of CD by sine of 30 since sine is opposite over hypotenuse. We know that all of that has to equal 0, so we were to solve for the force of CD. We would end up that it has a value of negative 473.4 pounds. Negative number means that it's in compression. From there, now I'm going to take the sum of the forces in the x direction. We have our force of BC, which I assume that is going to be in tension. So in this case, negative. From there, once again, we have our force CD. So we have negative 473.4 pounds. And since this time we're trying to find the horizontal component of it, instead of multiplying it by sine of 30, we're going to be multiplying by cosine of 30 because cosine is now adjacent over hypotenuse, and we're trying to find that horizontal component of the force. So if we were to solve for our force CD, we'd end up getting that, force BC. We would end up getting a value of 410 pounds positive, so that means that it's in tension. So now we could come up here and put that we have solved for this one and this one. The next joint that I'm going to be doing is I'm going to be doing joint D. And we were to draw joint D, we'd have our joint D, we'd have it's to an angle, but in a way they're straight to each other because remember going up here, we have our member DC and DE. Yes, it's to an angle to us, but they are straight. And then from there we have just the member DB. So we found out that our member CD is in compression. So that means that it's going to be going towards the joint, not away from the joint. So that's our force BC, which we know that it has, sorry, CD, which has a value of 473.4 pounds. From there, I'm going to assume that the member DE is in tension, so away from the joint. So that would be the force of the member DE. Let me draw my joint just a bit bigger. So that's our joint. And then from there, we said that we have another member, our member DB. So that's our force of our member BD. So if you guys were to take a look at this, as you guys remember, when it comes to determining the forces of a member of a truss, there's these two cases, if you would call them, that help you determine those members or bars that are going to have a force of 0. And as you could see, this joint qualifies for one of those two cases. And it's the case where it says that if you have two forces that are both parallel to each other, and then from there, sorry, give me 1 second. That when we have three members that meet at a joint, so 1, 2, 3, and two of them are collinear, which would be in this case our force of our member CD and our force of our member DE. And there's no other external force or support reaction existing at that joint. So it's just these two and there's not another one. The force in the non-collinear bar is 0, which would be force BD. So that's how we know that force BD will simply be having a force of 0 pounds. And that would be because of case 2, which is sometimes referred to as the windshield wiper case. So we know that that force is going to be having a force of 0 since it's in the middle of um, two collinear members, and that one is the third one, and there's no more members. So it's just those three. Two of them are collinear, and one of them is non-collinear. Now, to determine the force of our member DE, I'm just going to be taking the sum of the forces in the x direction. So from here we have that negative 473.4 pounds. And then from there, we have our force of our member DE. We know that that has to equal 0. I'm taking the sum of the forces in the x direction because since they're collinear, I'm just going to be assuming that they're completely in the x direction. And then from there, if we were to solve for our force of our member DE, we'd end up getting that it has a value of negative 473.4 pounds. Since we got a negative number, that means that it's going to be in compression. And remember, we already determined also the value of our force from our member BD. Remember, because of that, those cases that you could use when determining the forces of the members of a truss. So with that, we solve for this one and this one. So the only member that's missing is member BE. I'm going to be using method of joints about joint B now. So from there, if we were to draw out joint B, we'd have our joint B right here. From there, we have our member BC going to the right to it. We know that our member BC is in tension, so that means that it is going away from the joint with a force of 410 pounds. Then from there, we have our member AB, which we know again is in tension. So once again, away from that bar, from that joint. From there, we would have our member BD, but remember that we already determined that it has a value of 0, so you don't really have to draw it out, but it has a value of 0, but it shouldn't be taken into consideration. And then from there, we would have our member BE. I'm going to assume that it's in tension, so away from that joint. So once again, I said that you don't have to draw out BD since we already know that it has a force of 0. So now taking a look at joint B, as you guys could see, once again, we have that case of a windshield wiper. We have two collinear members, and then from there we have that one non-collinear member. These two are both linear. This one's non-linear to it. We don't have another reaction or a force to it. We just have 1, 2, 3. So that means that our non-collinear member would have a force, or the non-collinear bar has a force of 0. So once again, we were able to determine simply just by looking at it and knowing that the case of the windshield wiper, that the force of the member BE will have a force of 0. Mm. So now that we go, as you guys can see, we have now determined all the forces in this truss. So once again, just a quick recap. To start off this fundamental problem, what I did is I first determined how many reactions there would be in this truss. From there, we saw that at joint A, we had a pin support, so two reactions, our vertical and horizontal reaction. From there, at joint C, our vertical reaction. From there, I proceeded to determining the values of our reactions. And then from there, I determined the forces of each of the members that were asked of us. So to determine the forces, I used the method of joints. I started off with joint A. From there, I proceeded to doing joint C. Then I did joint D, which in joint D, we were able to use one of the cases where we could simply know that that member has a force of 0 pounds. And then from there, I went to joint B to determine the last member. Once again, we had that same case. So we were able to determine that that member would have a force of 0 pounds as well. Thank you guys so much for watching this video. If you guys found this video helpful, please feel free to give this video a thumbs up, and also feel free to subscribe to our channel if you guys would like to see more videos like this.